Hello. So in this lecture we will be studying the dining philosophers problem with the theoretical concepts. So in dining philosophers problem, so if you observe this diagram, there are 5 philosophers like this one philosopher P0, then philosopher P1, philosopher P1 here, philosopher P2, P3, P4. They are sitting around the round table, and then there is a food kept in front of them. Let us write this as a food. Okay, so there is a dish kept in front of them, and they want to eat from this dish. So during the execution of this program, philosopher goes through 3 different states. Let me write the states as states. So the states are first philosopher will be in a hungry state, then philosopher will try to eat, so he will go into eating state, and third state is philosopher is thinking. So after eating he will start thinking. So these are the 3 states through which a philosopher goes. Now problem here is that every philosopher, that P0, P1, P2, P3, P4 requires 2 chopsticks to eat from this dish. They require to acquire 2 chopsticks to eat from this dish. So for example, P0 will require his left chopstick here. So this one is left for P0 and this one is right for P0. So P0 R and P0 left. Okay, so P0 needs to acquire chopstick 0 and chopstick 1 to eat from this dish. Okay, now here is the problem here in the philosopher. So let us understand it step by step. So there are 2 entities. First we will write entities in this problem. So first entity is the philosopher. So philosopher goes through these 3 different stages: hungry, eating, and thinking. And next entity is the chopstick. Okay, now problem here is there are n number of philosophers, and the number of chopsticks are also n, and required chopsticks are required chopstick for each philosopher is equals to 2. That means every philosopher requires 2 chopsticks to eat. So total chopsticks will be required as total will be equals to 2 into n. So that means there are 2n chopsticks are required, but as given in this example, there are 5 philosophers and 5 chopsticks. That means there are only n chopsticks available here. Chopstick 0, chopstick 1, chopstick 2, chopstick 3 and 4. So total 5 chopsticks are there, and philosophers are P0, P1, P2, P3, 2 P4. That means 5 philosophers. Okay, so the problem here is when P0 starts eating. When P0 starts eating, let us consider this P0 is in the eating state. He is in the eating state. So if P0 starts eating, then what will happen? P0 will acquire this chopstick and it will acquire this chopstick, CH0 and CH1. So P0 requires CH0 and CH1 for eating. Similarly, P1 requires CH1 as left chopstick and CH2 as the next chopstick or right chopstick. P2 requires CH2 and CH3. P3 requires CH3 and CH4, and P4 requires this left to P4 as CH4 and right to P4 as this CH0. Okay, so that means whenever P0 will start eating, at that time, even though P1 is in the hungry state and he wants to eat, then also he will not be allowed to eat, because this chopstick CH1 which is required by P1 is already held by P0. Similarly, if P4 is in the hungry state and he also wants to eat, then also he can't eat, because the chopstick CH0 right chopstick is required for P4, which is already occupied by P0. Okay, then the same thing will happen here. P2 is in the hungry state and he has both the chopsticks available, CH2, CH3. So P2 will go into the eating state. So if P2 is going into the eating state, this will go into the waiting state. So this will be in the waiting state, this will be in the waiting state, and this also is in the waiting state. So that means there needs to have some synchronization among these philosophers, so that every philosopher will get a chance to eat from the table or the pots or the food, and they will complete their all these three stages: hungry, eating, and thinking. Okay, so with this, so you might have understood the problem now. Problem here is there are n philosophers and n chopsticks, but maximum required chopsticks are 2n, but available are only n. So this is the problem of that means it requires to have 2n chopsticks, but there are only n. That means some of the philosophers will be in the eating state and some of the philosophers will be in the hungry state. And whenever the one of the philosopher will release the chopsticks, at that time some other philosopher will acquire it and will start eating. So this problem is called as the classical problem of operating system, and we have to learn two concepts in this problem. So first concept we are going. So first thing that we will understand with this dining philosopher problem is a deadlock. So deadlock is nothing but it is a circular weight. So circular weight is one of the necessary condition for the deadlock. So let us consider there are two processes, process A and process B. Okay, so these processes are executing like this. Process A requires some resources but which are occupied by B. So A is waiting for B. And B requires some resources which are occupied by A. So B is waiting for A. So here in this scenario what will happen? A is waiting for B and B is waiting for A. That means none of the process will get completed and they will be in the waiting state for the infinite time. So similarly this deadlock we have to demonstrate in dining philosopher's problem. So for instance consider that all the processes, process P0 is in the hungry state, process P1, process P2, process P3 and process P4 all are in the hungry state and they want to acquire the chopsticks. So what is happening here in this scenario? P0 is acquiring these chopsticks CH0, P1 is acquiring this chopstick CH1, P2 is acquiring this chopstick CH2, P3 CH3, then P4 CH4. Okay, so that means every philosopher have acquired their left chopstick. Okay, now what will happen? Now P0 requires one more chopsticks to eat from this pot because every philosopher requires two chopsticks. So, but this CH1 is not available, it is with P1. Similarly, P1 requires CH2, but it is with P2. Similarly, P2 requires CH3, but it is with P3. And P3 requires CH4, which is with P4. So this scenario is somewhat like this. P0 is waiting for P1, P1 is waiting for P2, P2 is waiting for P3, and P3 is waiting for P4. And in turn, P4 is waiting for this CH0. That means P4 is waiting for P0. So this is a circular wait, and this particular condition is called as the deadlock. And one more concept we have to learn from this dining philosopher problem is a starvation. Okay, so first we will understand a scenario here. Let us consider if P0 is in the hungry state. So he has both the chopsticks available, CH0 and CH1. So it will acquire this and this. So it will go into the eating state after taking these two chopsticks. Okay, then P1 will be in the hungry state and he doesn't have the chopstick available, so he will go into the waiting state. Okay, then what will happen? P2 is also in the hungry state and he has both the chopsticks available, so he will acquire the chopsticks CH3 and CH2 and will go into the eating state. From hungry state he will change its state to eating state. Okay, now next time what will happen? Let us consider that P0 has released its chopstick and went into a thinking state. P0 has released its chopstick and went into the thinking state. So this CH1 is available to P1 now. But meanwhile what had happened that P2 has acquired this CH2. So still this P1 will be in the hungry state. His state will not change because the another chopstick, even though this is free, the another chopstick which is required is occupied by P2. Then let us consider that this philosopher 2 has released this chopstick and entered into a thinking state. And meanwhile, what happened? That P0 is entered into a eating state. Okay, so if this chopstick is now released, but this is acquired by P0. So still the P1 will be in the hungry state. So same thing is happening, repeating again. He will go into the thinking state, but he will go into the eating state. So he will remain in the hungry state. Then again he will go into the eating state. He will go into the thinking state, and he will remain hungry. So this kind of the problem is called as the starvation problem. So this kind of the problem is called as the starvation problem. That means this process or this philosopher P1 is continuously remaining in the hungry state, and he is not getting the chance to eat. Why he is not getting in the chance to eat? If P0 is releasing this chopstick, at the same time P2 is acquiring the chopstick. If P0 is if P2 is releasing this chopstick, P0 is acquiring this chopstick. So he is remaining in the hungry state. So this problem is called as the starvation. Okay, so next lecture we will study the practical implementation of this dining philosopher's problem.